remember to help me out in the chat. Let me present the right thing. Okay. And let me get to the right lesson. Okay. So we are going to talk, oh, I didn't write the essential question yet. So we're going to talk about washers again. Okay. Let me make place here. Okay. So let me write out essential question and I can statements for you guys. So the essential question is, how do you calculate the volume, how do I want to say this, of revolution using a washer with a shifted axis. Okay. And then your I can statement is, I can calculate volumes of revolution using definite integrals and the washer method. And a shifted axis of revolution. That says revolution. It's bright pink. Revolution. Okay, I'll give you a minute to get that written here. Okay. All right, so we're gonna use the same example we did a couple of lessons ago, and we're gonna go through it 3 other different ways. Okay, I'm going to actually start with example 2 because we hadn't talked about the Y direction yet. So I'm gonna do the 2. We're gonna do a shifted one, and then we'll do the Y direction with some shifts in it. Okay, that's my goal. And I think that the Delta Math assignment kind of does both, if I assigned correctly. Now Delta Math is going to go all the way with these. I'm going to go all the way in example 2, but I am not going to go all the way in example 1 and whatchamacallit, 3, just because the setup is more important than us integrating all the way. You guys can get it integrated all the way on your own. Okay. So we got to find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1. I really should have done that in blue, right? Because they already gave it to us. It's a parabola shifted up 1. Y equals 0. I don't have brown, but I have got rainbow. So it's this y equals, sorry, it's not. That's just the axis, right? That's red. It's in red. X equals 0 is in green. And then x equals 1 is this thing right here. Okay, so that's the bounds of our region. So the region we are looking at is this guy right here. Okay. And we notice our axis of revolution, we're supposed to be going about. Let me find a different color. Let's use that one. About the line y equals -2. So I'm going to draw that in here. So y equals -2 is there. There's my axis of revolution. I'm going to get rid of my sparkly one because it's just too much. So do you notice how there's a big gap between the yellow and the axis of revolution that I just accidentally erased. Okay, so that's the indication that we're using the washer method. Okay, so if I'm revolving for my volume, what's the first thing that I need to do? What's the first part of my formula? Tell me in the chat. All right, it is in fact pi, okay? And we're lucky enough in this particular problem that it's really easy to see our bounds, right? We are definitely going from 0 to 1. If I couldn't understand that, I could set I could set things equal to each other, I suppose, but it's very obvious that it's 0 to 1. Okay, so now here's how we set this up. We know it's a washer, so I know I have to have the outer minus the inner squared. So outer minus inner. But within side of this, I need to do the top minus the bottom and the top minus the bottom. Okay? So inside each one of those. So what I'm looking at for my top curve on the first one, well, first of all, which one is your inner function? Is it the blue parabola or the red axis? Which one's my outer function? The blue parabola or the red axis? Tell me in the chat, what do you think? Yeah, the outer is the blue, okay? Because it's further away from my axis of rotation. And we're using the axis this time because it is touching it's the bottom part of the bound on the yellow, right? The yellow area that we highlighted. Okay, so my top is the blue, and that's the outer, and this guy is the inner. Now, if I'm looking at between the blue and my axis of revolution, my blue would be the top function and my axis of revolution would be the bottom function. So I'm going to take my top function, which is x squared plus 1, and I'm going to subtract my bottom function, which is negative 2. Are we okay where we're at? I need a thumbs up or something. Or a yes in the chat. Are we okay? Nate says he's okay. We're understanding Casey's okay. All right. So we're going to do that same thing again, but this time I'm going to use the red, right? So here is my, I'm going to do my inner function. So this is the top part of my inner function. This is the bottom part of my inner function. So my top part of my inner function is the 0, right? Y equals 0. And we're going to subtract my bottom part of my inner function, which is negative 2. Okay, so let's clean this up a little bit. I am going to integrate this one all the way because it is good to just practice that integration at least once a day, right? So the double negative is going to go positive everywhere. It looks like I've got pi from 0 to 1. This is x squared plus 3 squared minus 2 squared is going to be 4. Okay, I'm going to keep going because I'm not done simplifying, right? I could FOIL that out. I should have written smaller. All right, so we've got pi, the integral from 0 to 1. Let's see, when I FOIL this, I am seeing x to the 4th plus 6x squared plus 9. Make sure I'm doing it right. Minus the 4, which I could put the 4. I could simplify the 4, couldn't I? And it's better to do all the simplification than have to do like a weird product rule or a chain rule or something. No, Madison, it will not always be the bottom. Okay, and as soon as we're done with this example, before I do the weird axis, I'm going to let me explain that, okay? And we'll practice another version of it, okay? Just looking at the picture so we understand, okay? But very good question, okay? Because it won't always be the bottom. Okay, so let's go ahead and integrate. So we've got pi, and then we've got x to the 5th over 5 plus 6x cubed over 3 plus 5x from 0 to 1. Does the 0 matter? Am I worried about that 0 at the end when I calculate? No, I'm not. Good. Good, 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 good. Okay, so I'm going to plug in my 1. I probably didn't need to simplify there, but I did. Okay, plugging in the 1. We've got pi 1/5 plus 2 plus 5, right? So let's see, that's pi 1/5 plus 7. I put 7 over 5, I would get 35/7. So 35 fifths, not 7s, 36 fifths pi. Okay, I'm going to give you a minute to catch up, and then we're going to talk about Madison's question before I make an attempt at the other 2 problems. And you guys, if you've got questions, you have to stop me, okay? Because this stuff, this is the ugliest of the ugly on these. And if you're going to see this on the AP test, it's more likely to be this, okay? Than it is. Go ahead.
Ms. Ballard?
Yep, go ahead.
Can you explain the top and bottom part again?
Yep, we'll go through it again, and then you got to let me know if you understand it, okay?
Okay.
Okay, so 2 things going on. We've got the outer function and the inner function on the washer, okay? So my outer function in this case was the blue parabola because it's further away from my axis of revolution, okay? My inner function is the red axis because it's closer to the axis of revolution because they shifted the axis of revolution. So I know that whatever I do first, I have to work with the blue one first and then the red one, okay? So that's inner versus outer. Inside inner versus outer, I have a top minus a bottom, okay? So if I am going to try to figure out, remember when we're integrating a function, you integrate between the top curve and the bottom curve. So our axis of revolution is down here. So technically what I'm getting is all of this area in here. And then I have to subtract the area between the axis here and the curve, okay, in order to get the area that I really want, okay? So I figure out which one's on the top and which one's on the bottom for my outer minus my inner. And then I go to the blue is the top, okay? And then my axis of revolution is always the bottom. So my top minus my bottom. And then I have to shift down to my other function, which in this case happened to be the x-axis. So my x-axis or my other function was y equals 0, which was my top curve, minus my y equals -2, which is my bottom curve. Is it better, Anna, or no?
Yeah, I got it. Thank you.
You're welcome. All right, so now let's go back to Madison's question before I go on to example 1 and 3, okay? So Madison was asking, does the axis of revolution always have to be on the bottom? The answer is absolutely not. Sometimes it's on the top. So you just have to be kind of watch where this happens, okay? Let's say I have a very similar picture. Okay, so I'm going to draw another picture, and you don't have to write this down. You can just watch. Okay, let's say that my function, I'm going to go back to blue, is like this. Okay. All right, and then let's say that I still have a bound of the x-axis, okay? And then let's say my axis of revolution this time is up here. Okay, I changed 2 things on you at one time, okay? So if the green is my axis of revolution, help me out in the chat. Which function is further away from the axis of revolution? The red or the blue? Which one's further away technically? If this was say the area we were rotating. Yep, red is further away. Okay, so we would do the red is the outer in this case, and the blue is the inner. Okay, so I would have to do my red first, squared, right? Minus my blue second, whatever that function is. Okay, then I have to do top minus bottom. Okay, So my top is now the axis of revolution, whatever that is. So I don't know, let's just call it y equals 4 in this case. So we've got 4, right? Minus my red, whatever the red function is, okay? Then in the other one, my top function would still be the 4 minus my blue. That may, and Madison, are we okay now? Do we kind of understand that it doesn't have to be exactly the way I did it?
Okay, a few questions.
Go ahead.
So when you're looking for the outer and the inner, you're like doing that in reference to the axis of revolution?
Yes, exactly. Good job.
And same thing for like the top and bottom, like your axis of revolution is always going to be included, whether it's top or bottom?
Correct. Correct.
Okay, then I'm good.
Okay. So just, yeah, you guys are on, hopefully you've got the concept down. That the hardest thing is visualizing this mess. I'm hoping that you guys did the delta math and you could at least start visualizing the 3-dimensional. You don't have to know what it looks like 3-dimensionally, but you can at least see that that's kind of, they were showing you the rotations in there. I don't know if today's assignment does it or not.
That was so confusing. The like seeing how it was 3D. I was like, how does that even work? How do you even do that?
But I'm hoping that it got you, like, you know, because I mean, if you think about all the objects we have, none of them are just cylinders, right? So they're all kind of weird shapes. And this is like really cool because this is the math behind all those weird shapes. So, all right, okay, we're going to do the vertical question right now, Nate. I'm sorry that it snuck in there and I hadn't done a vertical question yet. So I'm going to practice vertical right now. We're going to do it in the concept of washers, but it works the same for discs as well. Okay, so let's look at number 1 here. So I'm scrolling back to 1. Okay, I borrowed these notes. All I'm going to do is this setup. Okay, so I'm not worried about calculating it. You guys have been integrating for a good full year plus now. You should be able to integrate it, okay? All we're going to worry about is the setup. So this time, the change that we're making is right here. We're rotating about the line x equals -1. And you want to see that word about. When you see that word about, that's where your axis of revolution is coming next, okay? So I'm going to draw that on my picture. And what I wish I could do is I wish I could like totally white out part of the graph. I wish I could white out this blue part of the graph right here. I don't know if I can get a white pen. Let's see. Let me add a pen. I don't think it'll let me add a pen. I have to change the color. Let's see. Can I get white? Oh, I can. Okay, let me white this part out. Let's see. Let me white. Oh, there we go. Okay, perfect. That was digital whiteout. Check it out. Isn't that nice? Okay, I love the digital whiteout. I don't know. It might almost be worth replacing my rainbow pen. Not quite. Okay. All right. So our region didn't change. Our region is here. Okay. That we're still rotating that. And then my axis of revolution, I'm going to still use the sparkly green. Okay. Is x equals -1. So I'm rotating around this. So I just changed the axis of rotation to a vertical axis of rotation. Okay. So the catch on this is, do you see how in this area right here, okay, I have this piece and the blue piece rotating, okay, whereas in this piece right here, I only have the brown and the green, okay? So I actually have to set up I have to set up 2 integrals and add them together, okay? So I'm going to label this. I'm going to call this region 1 and region 2, and this is only for my own purposes of trying to explain it to you. Okay. All right. So if I am just, I'm going to erase a little bit. I'm going to erase the orange that I had there. So if I am just looking at region 1, okay, so I'm just going to talk about region 1. Okay. And again, we're going to use the values that are on the graph. I'm not worried about trying to calculate those at this point. So I know that I have to start with pi. And again, it says, did you see this? This one here. The most magical words on an AP test ever: set up but do not solve. Okay, again, delta math is probably going to make you solve, but Set up a do not solve is awesome. So we're going to always start with pi. So pi. And then I'm going to say that this is region 1, just so you understand what we're doing here. Okay. So the catch on this before I get too far into it is that if I am rotating in the vertical direction, I need my equation in terms of y instead of x. So I need to solve this for y. Okay, so I'm going to do that first. So I'm going to get the, it's going to be y minus 1 equals x squared. And then I really only want the positive square root here because that's all I'm dealing with is this part of it. So I'm taking the square root. So that's the equation that I am now working with for that part of the graph. Okay. All right, so on the one that you got, Nate, on Delta Math, switch it to a y. Okay, so you got it. The first thing to do is convert it to x equals. Okay. All right, so now let's look at what we've got here. In this region 1, my brown would be my outer, which we were using red for, so I'm going to use red, outer. And my blue would be my inner function. Okay. And if I could, I would tip the piece of paper. Okay. Instead of top minus bottom, it's right minus left. It's always positive minus negative. Okay, so in this case, let's find something I haven't used yet. We're going to use right minus left. Okay. All right. So let me do my outer first. So outer goes here, squared. Oh, we got to integrate, right? I didn't write my integration down. Integrate. Where are we integrating to and from for region 1? Remember, you have to go in the y direction. What do you guys think? What's my integration from in the y direction there? From where to where? Look at it again, Nate. You're close. I like the 2. Where is region 1 starting? What y value? Ah, Madison, good job. 1 to 2. Okay, thanks for that, Nate. Okay, so we got 1 to 2, and I am going to do my outer function. And sometimes it helps. Maybe we should have labeled the graph a little bit. That is the line x equals 1. Okay, so my outer function is 1. And then I have to subtract my axis of revolution. So we're subtracting that axis of revolution because that's kind of this is the right function versus the left function. So again, this would be right. I used the wrong color. I should use this. Right minus the left. Okay, so I'm going to subtract the axis of revolution, which is -1. Okay. So we aren't done with region 1 yet though, right? Because we haven't done the blue function yet. So then I've got to do my inner function, my inner function. So minus the inner function on the right is the square root of y minus 1. And then again, I'm subtracting my left function, which is -1, and then we're squaring the whole thing. And then technically, I should have some parentheses around the whole thing and a dx. That's just region 1. This is why we hope they don't do this to us. This is a good to know. You should understand this, but it's rare that they set up a vertical. Okay, I'm not going to say never, but it's rare that they set up a vertical. They want to understand that you can do example 2. You can do the washer. This is cruel, isn't it? Because that's just region 1. Okay, we still have to do region 2. All right. The good news is the integration. If we actually were going to integrate this thing, region 2 is easier to integrate. Okay, so I'm going to go plus. Again, I'm going to start with my good old pi. Where is region 2? So if I'm looking down here at region 2 now, where am I integrating region 2 to and from? Do I need to go back, Madison?
I just like if it's a vertical problem, are you always going to have to split it like that? Like, is there always going to be 2 regions? Or
it's possible that you don't. It depends on where the bounds are.
Okay, so you just kind of have to know when there's
you gotta. That's why the picture is so important, right? If we had had if the region was up here, we would done this part up here, I would have only needed one.
Okay.
Okay, does you see the difference in the picture?
Yeah, we're gonna do more examples of vertical.
Yep, we're
right?
gonna do one more. There's one more vertical on here today.
Okay.
Yep, and this is why I'm focusing solely on the setup. I don't care about the integration right now because the setup is hard.
Okay.
Okay. All right, we're gonna try. Let's keep going. So let's see what else we can do with this vertical one. So I've got to do the outer minus the inner again. So I'm gonna make my outer red again. And I know that's probably a bad color. Let's see. This time it was green, actually, wasn't it? No, it's still red. We're gonna go red. Minus the green was the. So minus the green line is my inner function. All right, and I'm going to throw my parentheses and my dx on there. Okay, so my outer function is that line. So I'm going to use the line, so this is my right, okay? So I'm going to use 1 minus the axis of revolution. The axis of revolution, again, is always going to be part of it. Okay, and then I've got to do the inner function. The inner function on this one, I should have labeled it, I didn't. This is the outer on this part. This is the inner on this part. Okay, the inner is the line x equals 0. So 0 minus the axis of revolution, which is -1. Okay, and that's it. That's the whole setup. This is region 2. I should label that for you. Okay, I'm going to let you guys get it written, absorb for like a minute. We've got like 15 minutes left. We're going to try to do example 3, which is another setup, but do not integrate. All right, ready? So they're going to move their axis to a different spot. Okay, so hopefully that will help us. It's the same problem again, but they're going to move their axis to a different spot. Okay, so again, I am going to use my new, I shouldn't have changed it back to rainbow, huh? I'm going to use my new digital whiteout. Okay, come on. I'm going to white this guy out. We don't need that part. Okay, we're only still looking at this same axis of revolution. Sorry, not same region. Okay, that same region. Where you're going to, let's look at where it says we're solving. It says about the line x equals 2. We're going to just do setup but do not integrate. I'm not going to try to integrate all the way on this one. Okay, so I don't know why. There we go. So let's find the vertical line x equals 2. So that would be right here, would be this axis of rotation. I like to draw mine solid. Sometimes you'll see some teachers who will draw it dashed. Okay, so let's look at region 1 is this region up on top here. And then this is region 2. Okay, so the first thing you have to identify is, do you have a disc or do you have a washer? Remember, a disc touches your axis of revolution and your washer does not. So can you guys tell me if I have a disc or a washer? Okay, I know you're paying attention because it said washer in the top of the example, right? It has to be a washer. All right, so it is a washer. We are going to look at, let's look at region 1 to start. What do I always start revolutions with? What's 100% of the time, what do we start a revolution with? The formula. There we go. We always start with pi. Okay. Looking at this region 1, what do you think the bounds are again? Remember, you have to go in the y direction because it's a vertical revolution. Yep, 1 to 2. Excellent. Okay, and we're going to look, this is just going to be region 1. Okay, so you got to look at it again. We're looking at which we want to look for the function that is further away from your axis of revolution. So is it the blue curve or the brown line? So which one's further away from your axis of revolution, the blue curve or the brown line? Okay, so remember the orange, I know we've got 5 million colors. That's my axis of revolution, okay? So my orange is the axis of revolution. The blue in region 1 is further away than the brown. Okay, so we're going to use our blue first. So blue is going to become the outer. And then this guy here is still x equals 1, right? That's going to be my inner. Okay, so the blue minus the red, right? The outer minus the inner. Okay, my outer is still this function that we picked up here, right? It's still the x equals square root of y minus 1. I have to use the x equals version because we're doing a vertical rotation. It has to be in terms of y. So I have to do, oh, this one's weird, right? Because I have to do right minus left. So if I'm looking at the blue and the orange now, because that's going to be like my right and my left or my top and my bottom, okay? Which one's going to go first, the orange line or the blue parabola for right minus left? Good. Okay, so it's the orange is going to go first. So orange was 2. So I'm going to go with 2. 2, I used a different color in my axis this time, didn't I? And then minus the function, which is the y, or the square root, right? Square root of y minus 1. Okay, so that's it for that piece of it. Okay, so now we've got to do the inner function. All right, so the inner function, again, I have to do right minus left. So it's going to be the orange line, which is 2. And then I have to subtract the brown line, which is 1. Which I think sometimes the lines are worse because they're lines and they're just putting numbers, and all of a sudden these numbers appear, but they're really like, they're a function. Okay. Then I have to add that to, I got to do the second half, right? Because I still have to do region 2. Okay. These are going to make discs look great, don't they? All right. What am I going to start my integration with? What do I always start with? Tell me in the chat. Want to make sure you're still there. Haven't lost you. Okay. Pie. Think after this, we're going to need to go eat some pie. Okay, I wish I had one right now. I don't. Okay, and hopefully you understand that the bounds are from 0 to 1. Okay, and we're going to have to do, again, my outer minus my inner. Okay, so now I am looking at the red line here. That's got to be the inner. And the green line there, which is y, it's not y, x equals 0. So that's my outer because it's further away from my axis of rotation. So outer always goes first. So it's going to be the green outer minus the red inner. And this one's going to all be numbers because those are vertical lines, right? So they're all going to be numbers. Oh, thank you, Nate. You're right. I totally screwed that up on the last one. This should be a dy on all of it. Thank you. Let's fix that up here while we're thinking about it. I totally messed that up. This should be dy. Good catch. Good catch. All right. If it's vertical, it's y. If it's horizontal, it's x. Okay, and that you have to be consistent with your dy dx part. Okay, so if I'm going to go for my outer function first, the green one, right? So I have to do my right minus my left. So it's going to be orange vertical line, which is, we totally lost what the orange vertical line is. It's x equals 2, right? So it's going to be 2 minus the outer vertical line, which is 0. For the inner function, it's going to be the right, which is the axis of revolution, the orange axis of revolution, minus the inner function, which is 1. And that's it. You got your total, all the setup done. All right, are we still breathing? Anna says she's good. She's still breathing. If you get a pie, you will be. DoorDash. Polly's is on DoorDash. You can get a pie. All right. I know that one was challenging today. Okay. I didn't want to put. Did you not know that they are on DoorDash? I think it was free delivery too, if I looked the last time I looked. All right. You can get a pie delivered to your house. Can you believe it? So, okay. Madison, what's your favorite flavor? Now that we're talking about pie.
Probably pecan pie.
Oh, you like pecan, you like nuts. I don't like nuts.
I love pecan pie. Or like a second would have to be this mountain berry pie from Julian Pies.
Ooh.
That you can get at Winchester Farms. I love those ones.
You can get them at, sometimes get them at Stater Brothers too, the one in French Valley.
Yeah.
Yeah, they've got Julian Pies. Nate says chocolate cream.
Ooh, that one's
Anna,
good.
Anna, you like pecan pie too?
Yes, it's delicious.
Oh, my dad loves it, and so I've always like when I cooked for them, I always made one, but I haven't made one in years because I don't eat it. We're not nut people here. Peanut butter, that's about it. And Nate wants chocolate cream. You would probably like a French silk, Nate.
You can make us one, Miss Ballard.
We're gonna make you a pecan pie when we go back. Okay.
Yeah, hopefully.
So, we decided. I don't know if you guys are I don't think you guys were in the conversation last week. No matter what day we go back, we are going to celebrate Pie Day no matter what with pie, right? Even if